Section 5-3, Medians and Altitudes of Triangles. The objective of this lesson will be to apply properties of medians of a triangle and to apply properties of altitudes of a triangle. So let's go ahead and run through the definitions of these new lines that we're learning today. The first one is the median of a triangle, and that is a segment whose endpoints are a vertex of the triangle and the midpoint of the opposite side. So median is meaning that we find the midpoint of the side and then we connect that to the vertex point that is across that side. So that is your median. The centroid of a triangle is the point of concurrency of the three medians of a triangle. On the last video, you did learn about two different points of concurrency. You had the circumcenter and the incenter. This one is the centroid. So each side will create a median. So it'll connect to the opposite vertex. And where those three lines intersect is called the centroid. So right here, point P is the centroid of this triangle. Now the centroid is also known as the center of gravity. So this would basically be where you would be able to balance this triangle right here, and it would have equal weight all the way around it. So the theorem that is related with the centroid is your centroid theorem. And this says that the centroid of a triangle is located 2/3 of the distance from each vertex to the midpoint on the opposite side. So it's telling us, and notice they have the equations right here. The length of AP, this right here, is 2/3 of the length of AY. Okay, so this is 2/3 of this whole line segment right here. So you could say that this segment is 1/3 of this whole segment. Same thing for the other line, BP, the one that goes from the vertex to the centroid, is 2/3 of the whole length. And then the last one, CP, is 2/3 of the length of the whole median, which is CX. Let's go ahead and try our first example here. It says in triangle LMN, RL is 21. So let's go ahead and label that. So RL, this whole segment right here is 21. So I'm just going to point to this segment. And SQ, so from S down to Q, this segment is 4. Find each length. So A, the length of LS. So they only want the length from L to S. So this segment right in here. Now, if you remember your centroid theorem, it tells us that the length from the vertex to the centroid is 2/3 the length of the whole median. So if I had to write that out in an equation, the length of LS is equal to 2/3 of the whole median, which is LR. Well, we know the length of LR, okay, from L to R, notice they told us right here, is 21. So if I were to plug that in here, 2/3 times 21 would be 14. So that means that the length of LS is 14. B, it's asking us for the length of NQ. So right here, NQ, this segment now. Now remember NQ right here, our centroid theorem says that this length is 2/3 the whole length of the median. So if I could write that in an equation, I could put that NS is equal to 2/3 the length of NQ. So I don't know where SQ would go in this equation. But if you notice, if this is 2/3 of the length of this line, then SQ should be 1/3 of the length of that line. If I need 2/3 of that, that's going to be twice as big. So that means that the length of NS has to be 8. Okay, on this example, it says here, a sculptor is shaping a triangular piece of iron that will balance on a point of a cone. At what coordinates will the triangular region balance? So this one right here is asking us to find the centroid, which is the center of gravity. He wants to be able to balance this triangle on the point of a cone. So to find the centroid, I need to find the median, okay, which is the midpoint, using the midpoint of each segment and connecting it to the vertice on the opposite side. So for this one here, I need to find the midpoint of this side here, and I'm going to go ahead and use slope. So from this point to this point, I have a rise of 1, 2, 3, 4, and a run of -2. So I rose up 4, and I ran to the left 2. If I simplify that, it'll help me figure out where my midpoint is. So when I simplify this, I get -2 over 1. So that means if I go up 2 over 1, this right here is my midpoint. And I can go ahead and draw the line from the median to the vertex on the opposite side there. Let's go ahead and do the same on the other side. Sometimes it'll work out great, sometimes it won't. We'll get a decimal point. Let's hope we get a whole number. So I have a rise of 1, 2, 3, 4, 5 over 2. Okay, can't simplify this one. But 5 over 2, if we turn this into a decimal, is 2.5 over 1. So if I go up 2.5 over 1, that right there is my median, my midpoint. And if I connect that to the opposite vertice, I get that right there. Okay, and I can already see where the lines are going to intersect, so I don't need to keep going. This right here is going to be my centroid. So I know that the last line is going to go from here to there. So the centroid is at coordinate point 8, 5. So remember, you can use slope to kind of help you find the midpoint, but you must be careful, especially when you get into decimals. Make sure you understand your units of measure and how much each one is counting up by. Okay, good. Now we're going to talk about the altitude of a triangle. The altitude is a perpendicular segment from a vertex to the line containing the opposite side. Now don't confuse this with the perpendicular bisector. Okay, the perpendicular bisector would bisect the side. The altitude does not always bisect the side of the triangle, and in most cases it just doesn't. Okay, so the altitude is just the perpendicular line that goes from a vertex down perpendicular to the opposite side. Okay, so if you were to draw all three altitudes of the triangle, their intersection would be called the orthocenter. And in this triangle, the orthocenter is out here at point P. It's outside of this triangular region. And this is where the three altitudes intersect. So let's go ahead and work out a problem. Here they're asking us to find the orthocenter, which is the altitudes. Basically, that means the heights of all the vertices to the bases of the triangle. So let's go ahead and start by plotting this points. We have our first point at -4, 2. So this is point X. Our next point is at -2, 6. This is point Y. And then our last point is at 2, 2. This is point Z. Let's go ahead and connect these. So we have this triangle right here. Now, if you remember, the orthocenter is created by the altitudes. So I want the height of the triangle perpendicular. So if I had to create a line from Y to line XZ that was perpendicular, on this one it's not too hard to see that a perpendicular line has to go this way. because it creates the 90-degree angle right here. Now the other two segments, this is going to be a bit harder to find the perpendicular segment. We're going to have to utilize slope. And if you remember from chapter 3, I know it's been a while, but to find a line that's perpendicular to a line you already have, we're going to have to flip and change the sign of the slope. Okay, so this is for the perpendicular slope. So if I look at XY, let's go ahead and start with that one. Segment XY. His slope is the rise over the run. So we're going to rise up 1, 2, 3, 4, and then run over 2. So rise 4, run over 2. So the slope is 2 over 1. If I want a perpendicular line, the slope has to be, so the perpendicular slope, we have to flip this number, so 1 over 2, and we have to change the sign. His slope was positive, so his slope has to be negative. And we don't know where it's going to cross on here because it's not a perpendicular bisector. It has to be the altitude, the height. So we have to draw a line that has a slope of negative 1 over 2. Let's try drawing it here. Let's see our slope. Our slope is rise up 1 and then to the left 2. Rise up 1, to the left 2. Okay, it's looking like it's working. This right here would be the altitude of this line. This is perpendicular here. And we can see already that it's going to bisect right here. Let's go ahead and find where the last altitude would go. So for segment YZ, let's find his slope. From Z to Y, we're going to rise up 1, 2, 3, 4, and then run negative 1, negative 2, negative 3, negative 4. So 4 over negative 4, which is negative 1 over 1. To find our perpendicular slope, we have to flip it. So it's still 1 over 1. But we change the sign. This one's negative, so this one would be positive. And since we already know where it's going to intersect, we can go ahead and draw it this way. And we can check the slope just to be sure. We're going to rise up 1, run over 1, rise 1, run 1. The slope matches perfectly. And this is perpendicular right here. So the orthocenter is right here at coordinate point negative 2. So negative 2, up 1, 2, 3, 4. This is our orthocenter at negative 2, 4. Okay, so make sure you've filled in your chart. You understand what each of these points of concurrency are. You should know 4 of them already. Know how each one is created and know the special properties of each of these points of concurrency. Make sure you come to class with questions if you don't understand. That way we can help you a lot better.